Hey guys, this is the third part of the Advanced Java. In this lecture, I'm going to talk about only one topic. Java generics. What is the motivation that we need to talk about the Java generics? Let's start with this assumption. So assume that Java doesn't have, array list. Yeah, so you know that how much we use this array list guy. So let's assume there is no array list for, in the Java collection. So if we need something like that, something like the array list in employee class, then we would need to develop something for that, specifically for employee class. And uh, let's say later on we need something for the cat class. Now we need to customize that array list for the cat class, and so on. So it means that for every class that we create, we should customize that array list for that particular class. This is very, strange in the developing world, right? So that's why Java introduced the generic type. So what is the generic type? So first of all, the generic is equivalent to general purpose, right? But the generic is more popular, so we use the generic uh, keyword for this. So, and the generic type looks like this. And I am sure that you have seen this many times, in other courses. Anyway, so this E here is called type variable, right? And we can declare and instantiate this kind of Java generics like this example. So we just mention for what purpose we need this list or array list, and that's it. So very regularly we instantiate it. And here we just replace it with cat, right? Okay, let me give you some points about this um, syntax. First of all, on the left-hand side, we have list here, and on the right side we have array list, right? You know that the list is an abstract class or interface in Java library, and array list is an concrete class. Okay, so we usually use this polymorphic relationship, even though we can put array list on the left side here, right? But let's get used to this polymorphic relationship. It's more professional way of instantiating, declaring and instantiating this kind of classes. All right, and we could actually put the employee here and employee here, both side. But after Java 7, we can eliminate this guy from the second side, right? And yeah, we can reduce this verboseness of the code. So it makes the code a little bit less busy. Okay, so here is our official definition of the Java generics. Java generics, or a generic type, is a type that is parameterized by one or more variables. Okay, so we can put a variable here, and these variables are here are called type variables. Okay, so maybe someone asks, how come we didn't mention this? This is a type, so but we didn't mention this in the Java types before, right? Yeah, we didn't, but we did actually. We didn't mention that it's a generic type because generic type is actually a class. So we mentioned that, right? Okay. So now let me give you some rules and regulation about the Java generics. Okay. So we can use, first rule is we can use any legal keyword, any legal word here. We are not supposed to put it just one single character, right? But traditionally, we use a single character. So this is the point number one. So when I say legal, it means that it shouldn't be a reserved word or non-keyword word, right? Okay, so we might have several type variables, okay? And if this is the case, just comma separate them like this. E, comma, F, comma, so on, right? And the order doesn't matter. That's a very important point. The order does not matter. In fact, these guys, these variables, like any other dummy variable, will be replaced with an actual value. Yeah. Another point is, uh, the when you have a parameterized class, uh, that variable can be replaced with classes or interfaces, right? So, for example, we for the list we change it for the employee, which is a class, right? So we can put even interface here, that's okay, but not primitive type. We are not allowed to put a primitive type. And one reason that we introduced the wrappers for the primitives last time is this. Now you can for example have a list of integer, but you cannot have list of int. That's not allowed. Okay. Another point is we don't have any type subtype relationship between the between these generic types. What does it mean? Let me take an example. Look at this. We have employee here, a list of employee here, and a list of the manager here. Since manager is a subclass of the employee, we cannot say that this variable is a subclass of this variable. There is no such relationship. Actually, we can change a little bit, the format, and we make it, we make the type subtype relationship. That I will talk about that later. But for now, just imagine that, assume that there is no such relationship between these two generics. This section is dedicated to generic methods that are very, very useful. Sometimes they are really, really very useful. Okay, so what is the definition of generic method? Generic method is a method that it has some type variables. Okay, so I'm gonna explain that via an example, and I will show you that example in a live demo. Okay, so our goal is to write a generic method that it can print all elements of an array list. And since array list is a generic type, so we don't know what type of the classes are gonna be passed to this method, right? So that's why it is a generic method. Okay, so let me bring up my Eclipse. Okay, let me create a separate package for that. Um, let's call it generic method and finished a new class. Let's call it generic methods method, right? Okay, so public, um, we can make it static or we can make it the regular. Let's see, void and print list, and we're gonna pass a list of, okay, so we don't know what it is, so we say a, and let's call it a list, and then okay, so it's complaining about two things. The list is not imported, so we import that, and now it is complaining about this e. What is this e? So we need to put it here, something like this, to tell the Java that we are gonna write a generic method. All right. Okay, so now we have the list, just in a very simple enhanced for loop. We are gonna iterate over this list and print them. All right, so it's very easy. So just imagine that list, this guy, what is the elements, the types of the elements of the list is E. Since we don't know right now, we just do say E and element and a list. And inside this, we just uh, print it. Okay. And again, this E is not known right now, but we know that Java will call its toString. Okay, so how can we test it? So I'm gonna create a main method to test it. Main method. All right. So let me create a list of a string first. So let's say str list equal to new array list, and array list is not control1 import, and just populate it with something, str list add, let's say my name, the laziness, just copy and paste, let's say Tom, and let's say Mari. All right, so now, okay, so for simplicity, let me make it static to be able to call it without instantiating this class. All right, so just print list and pass str list. All right, let's see how it works as a Java application. Yeah, you see. Okay, so now we can test it with, let's say, a list of integers, just integer, call it int list, and let's see, int list add, let's say 3, and copy, and let's say this is 1, and this is 5, and let me comment out this to don't disturb us. Oh, we don't have the print. Where is the print? Print list, int list, right? And go ahead, and that's it. Okay, now let's get back to our presentation. The code that I just show you looks like this, and and I show you how we can call it. So you saw that, calling a generic method is exactly the same way that we call a regular method. So there is absolutely no difference. Okay, so now let me give you some points about the generic method. Uh, we can define a generic method inside a regular method, as I just show you, or it can be inside a generic class that I will show you in a few minutes. So no difference that what kind of class you have, you can put your generic method inside that. And also, if we have more type variables, we just, as we mentioned before, we just comma separate them. Um, so here is the place. Just comma separate them if you need more type variable. All right, and also the order doesn't matter. We mentioned this before. In this section, we are going to talk about generic class. So what is generic class? It's a class that it has one or more type variables. I'm gonna explain generic class via an example, and we're gonna have a live demo about that. So here is the example I am going to implement. So we want to create a generic box that we can put any kind of object, like integer, string, cat, employee, whatever, right? We can put some object inside that, and also we can remove them. All right, and to show the contents of them, we will have a third method that prints its content. Okay, so what would be the underlying data structure? So we can put something like array list, but I would suggest that, we put a set, hash set, and let's see what would happen. Okay, so let me bring up my Eclipse again. All right, and we would need a new package for that. Let's call it box, or let's say generic class. And inside the generic class, we create a new class and we call it box. Okay, so let's see what we got here. First of all, I would need an underlying data structure. As I said, I'm gonna use the set and this E, and let's call it object list equal to new hash set. So the set actually is the interface. First of all, let me resolve them. And hash set is an implementation of the set. Now it's complaining about this E again. Yeah, it is right. So this time we put the E here in front of the class name. All right. Okay, so in this class now, E is known, right? It is a known object from now on. We can use it easily everywhere. Okay, so let's start with the put. So the put will be just a public. We don't need any return. So put what? What's the type of the object? E. Yeah, just let's call it E. Okay, so our object list just add what? The E. Yeah, exactly. That's it. So for simplicity, I'm not gonna put some, fancy checking and this kind of thing. So because I'm trying to transfer the concept, as simple as possible. Okay, so another requirement was to remove. Uh, let's return something. Yeah, when we are removing that object, let's return it as well. Just to show you that how the return type um, works. So remove what? E again. For removing object list, fortunately we have a remove here, and we just remove that. And and yeah, it's complaining what's the return E. Yeah, return E. And for the print, I think we had seen that before. So public void print, let's say content, and it doesn't need anything. And we just need a simple for loop for EE and object list. All right, sys and just show it for me. Okay, I think we are gonna have a fun testing here. Okay, so let me add a main. Again, for the simplicity, I don't create a JUnit. I think we had enough, experience and practice for that. Okay, so we need to instantiate a box. Let's say box. Yeah, for simplicity this time, just integer. Let's call it box equal to new box. All right. And let's put something inside the box. So box, we have put, let's, for example, 5, and let's, this is 3, this is 1. Okay. Yeah, just show me the print the content, and then, okay, so up to this point, let me show that how it is working. Yeah, 135. So the order doesn't matter because it was a set. Yeah, yeah. So and you know that set and hash set are very useful. One of the interview question is, are you familiar? Oh yeah, this problem. They would ask you, okay, we have a list of objects, and there are some duplicate objects inside that. How can we eliminate this, the duplicate things? Yeah, you would say very quickly, yeah, we just create a hash set and insert all of those objects inside the hash set, and hash set is implemented in such a way that it eliminates the duplicate things. So this is the easiest way to do that. Okay, so you just learned one uh, job interview question. Okay, so another thing I wanted to check is to check that our remove is working. Let's remove the 3 and yeah, just print it again and see what would happen. Oops. So let me comment out this because it's intervening our job. Yeah, you see the 3. So this is the generic class, very simple. Okay, let's get back to our presentation, and I put the code here for your reference. We continue talking about Java generics, and in this section regarding the type bound, which is a very important part of the Java generics and very confusing, let's say. So let me give you some motivation that why we should um, talk about this type bound. Okay, we are gonna write the code. It's a generic method that it appends a list to another list. Both of them are identical. All right. So since we are familiar, uh, I just show you the code. So we have two lists. Let's call it A, and another list which is B, and both of them are the same type. And since this is a generic method, I need to mention the type variable here. And just to append this method to this method, we just go over to this method and add them to this list. I mean list, right? Okay, so this is just a simple for loop. Yeah, so we have B here, which is type list of E, and in each iteration, it creates an element of the list, which is E. We don't know exactly what it is, and just it adds to the list of A all of these elements that in each iteration are coming from the B list, right? So it's very simple, right? Do you see any problem here? Yeah, you can pause the video and see, do you see any problem here? Yeah, probably you would say no, everything looks good. If you say no, yeah, you're right. There is no problem at all here. But after we implement this method, new requirement is coming. They are saying that change the method in such a way that we can add some subclasses of elements of A to to the list of the A. For example, we have list of employee, list of the manager, and we know that the manager is a subclass of employee, right? And we're gonna change that method in such a way that our second list can be manager as well, right? Let's see how can we uh, do that. So the first question is this guy that we have seen in the previous slide can be used or reused for this purpose as well. So you remember? So both of these lists, list A, list B, both of them have the same type. Yeah, probably most of you guys would say no. Why? Because the employee and manager are two different types, even though there is an is a relationship, but the method the method doesn't care about this right now. The method is saying that I expect to have E and I expect to have the same type here, but they are not the same type. And the method doesn't know anything about the polymorphic relationship so far, right? So definitely the answer would be no. Okay, so how can we implement that? Probably you would say, It's no problem, just add another type variable." Yeah, that's it. Here is the code. So I say this is E, but this is F. And since we have two type variable, we need to introduce two type variable here, right? And now we are gonna go over this list, which is the F here and here B. So we put the B, the list here, and here we put the types of the elements here, right? And we just add them to the list of the A. How about this? Do you see any problem here? Yeah, you are right. Yes, this code won't compile at all. Why it won't compile? Because we have two different types here and we are adding one type to another type. And this is strictly prohibited in Java. And Java is proud of itself about this kind of type checking, right? So this code is not a good code because it doesn't compile. All right. How can we resolve the issue? That's the role of the type bound comes up. How? So we can bound the type variables like this. Look at this. We can say, all right, I have E here, I have F here, but F, we can explain that. F extends E. Fantastic. When we say this, it means that we define F now as a subclass of E. Fantastic, right? So F extends E is equivalent to F is subclass of E, or F inherits from E, and it shows clearly that there is a class, subclass, superclass, subclass, or subclass, superclass relationship between F and E. Okay, so yeah, type and subtype relationship. So if we put employee here, a list of employees, and a list of managers here, right? Then this method works fine. Not only the managers, but also all of the subtypes of the employee. For example, if the employee is here and if the manager is here, and if we have something, let's say, whatever, we don't care, X here, we can pass the E here and the X here, because this is saying that all of the subclasses relationship, it should work. All right, fantastic. Okay, so I put an exercise for you guys here to check this. So you're gonna to make two classes, employee and manager, and um, manager extends employee, and verify that that method is working fine. We continue talking about Java generics, and in this section about the wildcard, which is a very important section and very confusing if you don't learn, precisely what they are. Okay, so a wildcard, like any wildcard that you have seen so far in your operating system, in regular expressions, and so forth, the wildcard is, you can replace or, it describes a family of types. You can replace a family of types with a wildcard. What does it mean? Yeah, I will explain that via, some examples. But before going further, let me tell you that in Java generics, we have three flavors of wildcards. The first guy is just a question mark, and it stands for all types. All right. So if you put some, for example, the box, for example, and a question mark, something like this, it means that any type. It can be any type, and we call it unbounded wildcard. Another one is we saw this X extend something. I'm sorry, question mark extend something, and it stands for that all types that are subtype of this guy. So you can pass here anything, any object which is a subclass of or subtype of the super type variable. And in fact, this is a wildcard with an upper bound. So this guy will be the upper bound for whatever we can put it here. And also we have the third guy, which is question mark super, a subtype here. So this is actually an opposite for with this one. What does it mean? Here we said something extend a super type. Now we are saying that something is super for this guy. So here we have superclass. Here we have the subclass. Okay, let's see now how it works. I am going to explain them via some examples. Probably the best example is our previous example, the method with two arguments here. Okay, so this is our previous code, right? Now our goal is to first of all learn the uh, Java generics wildcards, and also we are gonna eliminate or reduce this F from here and here. And let's see how can we reduce. Now, right now, this method has two type variables, right? We want to play with the wildcards and try to, eliminate one of these two. So let's focus on eliminating F first, all right? So here is our goal, to reduce the number of type variables to one by using the wildcard. So let's see how can we do that. So the first thing that we need to do is we should replace all of the F's with the F extends E, because this is the description of the F, right? So we have here, even though this code is working fine, we don't have any problem with this, but you know, so to introduce the wildcards and reducing the one type variable, we are trying to elaborate on this uh, method and see how can we reduce one of these type variables. All right. So first we replace wherever we have f. Yeah, it's already changed. We have one here and one here, right? Let's see how can we do that. So you see, we replace this f to f extends e, right? And yeah, we didn't change this yet. I will, explain about that in the next slide. But up to this point, if you compile this code won't compile. All right. So it's not finished yet. It won't compile. Okay, so let's continue. Up to this point, we have this. And if you are asking why we didn't change this F to F extends E, because Java doesn't, support that. It's a wrong, it's an invalid syntax. So we keep it here as a F, but we can replace it with E. I am telling you that instead of F, we can replace it with VE. Let's see how. How come it is possible? Okay, that's very interesting explanation. So let's focus on this part and let's say, let's explain how it works. So the B is a list of F's, right? And here we have the elements of F. Okay, and so in each iteration in this for loop, what would happen? One element of this list will be assigned to this variable. So f equal to e will be equal to one element of this guy, right? And since this is a relate, this is an assignment. This is a, let's say this is a very simple assignment, right? And we know that we can have a polymorphic, assignment here. How come? So if we change this to E is the superclass of F. So we we can have E here and then the element of the B, which are the subclasses of E, and this is totally a polymorphic relationship, right? So I wanted to prove that we can change this F to E without any problem. Okay, let's do that. Yeah, here is the explanation I just gave you. So this guy will change to this guy. Okay, yeah, if you compile this code, it is still does not compile. I am telling you. Yeah. All right. Now what? What we got so far? This is our final code so far, right? But if you look at this, the methods body, you see no references to f. So no f inside the method. Okay, so what does it mean? It means that f is not being used anymore. So in other words, these f and these f are useless right now. I can replace them with a wildcard. So I don't need anymore a second type variable, right? So exactly, we can change this f extends e to question mark extends e. And in this way, we can eliminate the f. No f is required. And when we do this, now let's look at this part. So if we don't have f here, we have a question mark here. So it means that during this guy, we have only one variable, type variable. So we can remove this part as well, right? We just need this E. Okay, cool. Now let's see how our code looks like. And this is our final code. So, step by step, I try to use our knowledge and all of the definition we have learned and the polymorphic relationship to prove that so we can convert a generic method from two variable type variable to one type variable by playing and using the wildcard. Yeah. So let me give you the side by side uh, representation of the code, and you see how we change this code, which was the original code, to this code. Okay, and this code compiled perfectly and works perfectly. All right, so now let me give you some notes about the wildcards. So we always use the keyword extends. So here, if we have class, if we have interface, we don't care. Always we use the extends here. And if we have two or more classes or interfaces, then we separate them with this and ampersand between them, so, like this. Look at this. So question mark extends comparable, which is an interface, serializable is another interface, and we have this ampersand. Okay. Also, in the previous example, we could replace the role of E and F, and we could, actually eliminate the E. How could we do that? Look at this code. Instead of using here that question mark extends E, right? We would say question mark super F. We're using the opposite side of the that's wildcards, right? And this F is coming here as well. And we just need one uh, type variable. Cool. So far, so good. Sometimes in the documentation of the Java, you might see something like this. And if you see this, this is just an old version of the Java API. Uh, you know, don't use them. Try to not using them because they are obsolete and they will be deprecated from the Java library. And I would confess that, type subtype relationship that I just mentioned here is very complicated. It's really, really more complex than what we have seen here. And also the wildcard. The thing that I mentioned here is just a taste about the wildcard. It's a long story, but I am telling you that I have never used more than this that I just taught you. So we finished the Java generics here. Uh, I gotta mention this point that Java generics is very important, very useful, and also very confusing. It can be very confusing, I am telling you. So be careful about that and try to do that exercise that I gave you, and also follow all of the examples I gave you. Try to implement by yourself and try to understand what is going on. I'm gonna stop here. See you guys in the next